Hello everyone, welcome back. So today we're going to learn about the zeros of functions. So our goals will be to understand what the meaning of that, what that tells us, and also be able to find the zero of a function by hand, and then also be able to find the zero of a function using a graph. Let's take a look. First explain what a zero of a function is, then look at some examples. So a zero of a function, so you have some function we call y or equals f of x. Then what's called the zero of a function is the number x that's the solution of f of x equals 0. So what that means, you just set your function equal to 0 and solve it, and that x value or values, could be more than one, is what's called the 0. Okay, now as we'll see graphically, that value is also the x-intercept of the function, so that value is a 0 is the x-coordinate of the x-intercept of the function. Okay, now are these zeros? A function can have no zero, one zero, or many zeros. Let's come over here to the right, look at the example. Let's say this is just our x and y axis. Okay, let's say you have some graph looks like this. This is our f of x. Okay, so these x locations where it crosses the x-axis, let's say this is point A, this is B, and this is C. So our zeros are x equals A, x equals B, and x equals C. Okay, those were the graph, the x locations where the graph crosses the x-axis. And once again, these are the solutions of f of x equals 0. So we take our function set equals 0 and solve it. Those values are the solutions to that. Okay, and these are also the x-coordinates of your x-intercepts. And also, if your x-intercepts, you can have potentially, you might have not any x-intercepts at all. That's possible. Or you can have one x-intercept or three x-intercepts or potentially as many as you want. Some functions will actually have an infinite number of x-intercepts or zeros, an infinite number of zeros. Okay. Now, let's talk about how to find one by hand, how to find a zero of a function. First, by hand is just start with our function and set equal to 0 and solve. So here, I'll just say our directions say to find the 0. I'll say plural, although there might only be one or even none. Okay, so let's say we want to find the zeros. So number one, let's say we have let's start with a linear function. F of x equals 2x plus 3. All right, so with this one, what I want to do is I want to solve f of x equals 0. That means we want to solve 2x plus 3 equals 0. Okay, so we simply solve for x. So subtract 3 from both sides. We have 2x is equal to negative 3. Then divide both sides by 2. X is equal to negative 3 over 2. And that is our 0. Okay, so this value is our 0. In this case, there's only one. Okay, and also our x-intercept of our graph has the coordinates negative 3/2, 0. Okay, let's take a look at this one on Desmos. Here is Desmos, DSMOS.com. Let's type that in, and what I'll do is y equals 2x plus 3. Okay, and actually it shows us both y-intercepts and our x-intercept, and that's it right there, negative 1/2, 3 divided by 2 is the same as 1/2, negative 1/2 is 0. Okay, so as the next part will say, so graphically, as I said, your 0 is where the graph crosses the x-axis, the x value at that. And so our 0 here is the x value is negative 1.5. Okay, in this case, that's the only one. All right, number 2, let's do a quadratic function this time. Let's say we have f of x is equal to x squared minus 2x minus 15. Okay, so once again, we want to solve f of x equals 0. So take our function, whatever function is, set it equal to 0. and solve. Okay, so I have to solve a quadratic function or quadratic equation. Now this one is actually one you can factor, but you can always use the quadratic formula. This one will factor into x minus 5 and x plus 3. And so set each factor equal to 0. So then our solutions to this are x equals 5 and x equals negative 3. And once again, these are our zeros. And these are also our x-intercepts of our function. Are 5, 0, and negative 3, 0. So also let's graph this on Desmos to show this. Now let's just turn this one off. And so we have x squared minus 2x minus 15. Okay, so we have a parabola. I can zoom out of it, show it as a parabola, zoom back in. Now, actually, these dots show where our intercepts are, negative 3, 0, and 5, 0. So once again, our zeros are negative 3 and 5. Okay. All right. Now, that's how we can solve by hand. But now, not every function will have a 0 we can find that way. Let's actually do a quick example. It's number 3. What if we had f of x, a constant function, f of x is equal to 2? Okay. Well, once again, what we try to do is try to solve f of x equals 0. We do that, we'd have 2 is 0, which of course is false. It's not possible. There's no x, and then we can make this true. So in this case, you'd have no zeros and no x-intercepts. Okay. This is just a constant function. So that's one example, one that has no 0. Okay. So if we graph that really quickly, f of x equals 2, so y equals 2. Recall, that's just a constant function at 2, and it never crosses the x-axis, so it has no 0. Okay. Now, let's also talk about solving by graphing. Okay, this is where in some functions, it may be difficult, maybe impossible to find the value by hand, so we better to actually graph it. Let's take a look back here at Desmos. Let me just turn these off. All right, let me make up another quadratic function. We'll see what happens. Okay, so let's say I do x squared, okay, minus 3x minus 17. Oops, sorry, that should be up. There we go. Okay. Now, this one is one we can always solve with the quadratic formula. Might factor, though I doubt it. But, where are zeros? So our zeros are the x values of our intercepts. So our zeros, in fact, let me come back and write this down. Let's do a number 4. Let's go and do this. So I can just go down here. And I said, so number 1, f of x is equal to x squared minus 3x minus 17. I believe that's what I picked. Right. Okay. Now, if we plot this, once again, I'll just do a very basic graph since we can see it right here. Okay. So our intercepts are negative 2.887 and 0. And the other one, the positive one, is 5.887 and 0. Okay, so then our zeros are approximately, these are approximate values. X is approximately, for the squiggly, this we use the squiggly line, 1, negative 2.887, and the other one is approximately 5.887. Okay, that's when we can find those by graphing. Now you can also, this is when you definitely can use the quadratic formula. You can solve it that way. Okay, let's go back to Desmos just a minute. Now, what if I had a different one? What if I changed this one instead of plus, made this a plus 17? Okay, now, don't see it anymore, but it's still a parabola. So we zoom out. Okay, notice it doesn't cross the x-axis. Therefore, this one would not have any zeros. What would happen then, if you solve this one as a quadratic equation, you find out that actually your solutions are imaginary. They involve complex numbers. That's one way to tell that you don't have any zeros. Okay. This is also useful. There are some functions, I was mentioning some functions that even have an infinite number of zeros. For example, the trig function sine of x. Let's zoom back in. Okay. Basically, it crosses the x-axis at an infinite number of times, but regular places. So every multiple of pi. So 0, pi, negative pi, over here, 2 pi, basically 3 pi, and so forth. So actually, it's an infinite number of zeros. Okay, it crosses the x-axis an infinite number of times, and so they're all regular. Basically, they're all multiples of pi, plus and minus. Now, finally, you mentioned one reason why this is important is you might have some really complicated equation that maybe there's no way you can actually solve some function and to find the zero of it, to find out where it's going to be zero, it may be impossible to actually find it by hand, so we have to do it by graphing. So let me make my function x squared minus, let's say, the sine of x. Plus, what do I do? Log of. Okay. Now this is one. This function right here is something. There's no way that you actually get x by itself in this. It's actually impossible. But to try to solve it by hand, you have to solve something like this by graphing or some other method. So by graphing it, we can find out that that's our zero. Okay, about 0.934. And many times that function, that value is really useful. And you actually can do this in some ways to use a method like this, actually solve equations which are sometimes too difficult to solve, by actually treating them as functions and finding out where they equal zero. Okay, let's briefly review. So a zero is basically the solution of, or where you set the function equal to zero and solve, that's your zero. And also that's the same as the x location of your x-intercept. So we found out how you can find the zeros of functions by hand if possible, then also through graphing. Thank you. Have a good day.